atom, J. Okay, and now when you look at many electron atom, you also have the spin-orbit coupling. However, it's more complex comparing to the hydrogen atom. Yes. And finally, you will see or you consider and you will discuss about the X-ray spectra. Yes, you already know the emitting spectra or absorption spectra, emission spectra, and absorption spectra. And now you also can consider one thing is emission and absorption spectra. However, the spectra here is X-ray. And X-ray is one of the characteristics of the atom spectra. However, you can consider how and why and when. Yes, and from the look about the X-ray spectra, you will see some application of it in the experiment or in science. Yes, that is the some section in chapter 3, and now is the chapter goes. I'm sorry. Yes, it is goes of this chapter. In this chapter, or by studying this chapter, you will learn how to analyze the structure of many electron atoms and how X-ray emitted by atom reveal their inner structure. Yes, it is their inner structure. The inner structure of atom. Inner structure of atom. So the inner structure of atom regarding to the configuration or electron configuration, or you can also think about the cell or the energy state inside the atom. And from the X-rays emitted by atom, you will consider or you will discover something relating to inner structure. Yes, and this is the learning roles of this chapter. Yes, and firstly, we consider the Schrödinger equation for many electron atoms. Yes, I will go fast in this section because it's too difficult for you. I only talk some main things relating to this. Firstly, you also apply the Schrödinger equation in general form for one electron in many electron atoms. For example, you can have a nucleus here and on the cell. I'm sorry because I think my pen has some problem. Yes, this is the electron outer or in the cell in many electron atoms. And for example, you consider one electron here and one electron here, and you have a lot of electrons around. And at this or here, you only consider one electron. For example, you can consider electron at this position. And besides the potential function between electron and the nucleus, you need to count or you need to consider the potential function or the potential energy between this electron and other electron, E2, E3, E4, and many other electrons in this atom. So in centrifugal approximation, you will have the Hamiltonian contain two parts. The first part is the kinetic part, and the second part is the potential. And in this, you have the potential approximately equal to K G effective E squared divided by R. In hydrogen, you only have the potential K E squared divided by R. However, in this, you can see there is an adding adding or the addition E G effective factor here. And in this case, G effective is effective charge of nucleus with respect to current electron. Yes, it is the effective charge. Because beside the potential with the nucleus, electron will have many electric potential with other electrons. So the sum or the total of these potential, you will have an effective G here. Yes, and the potential function U change comparing to Schrödinger equation of hydrogen atom. And from this, you need to apply some approximation. Approximation here is gần đúng. Yes. Với lại cái hàm thế này thì chúng ta phải áp dụng, các nhà khoa học phải áp dụng nhiều cái phép gần đúng để mà giải ra cái hàm sóng cho cái điện tử đang được Z này. Đó, thì cô sẽ không nhắc đến các cái phép gần đúng đấy như thế nào nữa vì nó cũng quá là làm nhằng đối với lại chúng ta. Như vậy chúng ta sẽ chỉ cần quan tâm là người ta vẫn giải nó theo cái cách cũ. Đó là vẫn đặt cái hàm sóng phi bằng 3 thành phần là bán kính, góc và vẫn giải 3 phương trình Schrödinger như vậy. Và đến cuối cùng người ta vẫn ra được hàm sóng cho từng trạng thái. Cái này các bạn không quan tâm, các bạn chỉ biết rằng người ta có giải con đường như vậy. Vẫn giải ra đâu rồi? Ok, vẫn giải ra nghiệm và số 1, số 2 rồi mà chưa thấy có số 3, số 4, số 5. Rồi, người ta vẫn giải ra và đến cuối cùng là người ta có được cái is not given by 3 quantum numbers. Is given by 4 quantum numbers. It is N, L, ML, and MS. And each energy level now can be occupied by 2L plus 1 electron. We have different quantum number ML and MS. Yes, but this is the difference between the many electron atom and one electron atom like hydrogen. Because in hydrogen atom, you will have E is a function of N. E only depends on N. However, in many electron atoms, you can see here, E depends on not only N, but also L. Yes. One energy state can be determined from the 2 quantum number, N and L. Yes. So from this, you can see that one energy level can be occupied by 2 multiplied with 2L plus 1 electron, different electron. Yes, because energy does not depend only in N, but also in L. So one energy state can be determined or can be occupied by 2 multiplied with 2L plus 1 electron. Yes, the restriction on values of the quantum number. You also have the restriction of quantum number. N is from 1, 2, 3, 4, 5. Yes, similar with hydrogen atom. And L is also, and ML also lasts from the minus L to plus L. And MS, you also have two values of MS. It is plus and minus 1/2. Yes, and it's similar with the hydrogen atom. However, you have two different. The first is the quantum number, a quantum number in one state, and the second is the energy state can be determined from two quantum number n and l. Yes, there's a difference between the atom, hydrogen atom, and more than one electron hydrogen atom. And from this, you can see here, this is a graph for energy. Graph for energy. Yes. Yes. You can see with the system with one electron here and the system with more than one electron here. So you can see with n equal to 1, it determines one energy state, and n equal to 2 similar, n equal to 3 similar. However, in more than one electron, you can see that if n equal to 1, you only have one values of L. So you have one or the only energy level. However, when n equal to 3, n equal to 2, you have two different value of n. So you have two different energy level here. Yes, and in the cell n equal to 3, you will have three different values of L and you have three different energy level. Yes, because in this E depends on not only n but also l. Yes, so you can have the different energy like this. Yes, so or you can see here, this is the description of the difference between hydrogen atom and more than one electron atom. Energy state is given by n, and this energy state is given by n and l. And in this quantum state is given by 4. Yes, it's finally it's a 4 quantum number. And this is also 4 quantum number. And the third is each energy level can be occupied by 2n square electron. And in this, each energy level can be occupied by 2 multiplied 2l plus 1 electrons. Yes, yes, because you can see it's 2n square because, for example, here, for example, hydrogen here, you can have two occupy an electron here. The first is with a spin up and the second with a spin down. And then in this, you will have two cells, subcell. And for example, the 2s, you will have two electrons with the opposite spin. And you will have more than 6 with spin up, spin down, spin up, spin down. Like this. And the total electron here is each H, and it equal to 2 square. Oh my God, why my pen like this? Yes, H equal to 2 multiplied with 2 square. Yes, or equal to n 2n square. However, in this, because the energy split into 2 energy level or 3 energy levels or 4 energy levels, so in each you only have 2l. Oh my God, 2l plus 1. 2s plus 1 electron can occupy on this. Yes, it is different between one electron atom and more than one electron atom. Pauli exclusion principle. Yes, it is. I already say it is the 原理loại trừ Pauli. Nguyên lý loại trừ Pauli. Yes. So the power exclusion principle said, the question for you in this section is, in many electron atoms, why electrons cannot all be in the same lowest energy state? And the answer for this is that, for example, you consider three adjacent atom or element in the periodic table. For example, fluorine, neon, and sodium, with a charge number equal to 9, 10, and 11. Yes, 9, 10, and 11. And if all of electrons are in the same energy level, all electrons are in this energy level. For example, 9, 10, or 11 are in the same lowest energy level. So from this, you can see that because all electrons in the same energy level, so I can predict that the physical and chemical property of these elements are the same, because it's does not different from together much large. There is a difference between them is the more than one electron in this energy. However, you can see that fluorine, neon, and sodium, they have the very, very different properties or chemical properties. You need to remember about the properties of fluorine and neon and sodium. And I would like to ask someone about the chemical property of this element in chemical. I can ask you about the chemical properties of fluorine, neon, and I would like to ask Kit, can you remember anything about the fluorine, neon, or sodium? Yes, it is nó là phi kim mạnh nhất đúng không? Rồi, it is a halogen element. Okay, belonging. Yes. Phi kim mạnh có nghĩa là con có thể giải thích là phi kim mạnh có nghĩa là sao không? Độ âm điện. Yes, it's easy to add one more electron to become minus F. Is it? Yes. And continue. Neon. Yes. However, you can see neon adding one electron to become neon minus one. Yes or no? Yes or no? Yes or no?
Nhưng con neon phải hình trơ à?
No, yes. It's no. It cannot happen this because it is inert gas. Inert gas. Đó chính là cái từ khí trơ đấy. Các bạn chưa nhớ thì các bạn ghi vào. It is one of inert gas. Yes. It's a khí trơ. Cái này là khí trơ nhé. Yes. It cannot receive one electron or release one electron to become iron. Yes. So in the chemical, you said that, yes, neon cannot react with other elements to become compound. Yes, it cannot react with other or combine with other elements to become compound. It has no chemical properties. Yes. I think that the reaction between neon and other element is very, very, very loud in the level. Yes. Thank you, Kiet. One more sodium. Kiet.
Sodium.
Yeah. Yes. So it's easy to adding one more electron or release one electron to become iron. Give, yes, give electron to become natrium plus. Yes. So as you can see, the chemical properties of some of these elements, they are similar or different from together. The chemical properties the same or not same? Get. Yes, very, very different together. Very, very different together. Yes, one has the oxygen properties and the second has no oxygen. Okay, okay, and yes, và một cái nữa thì là có tính chất khử, đúng không? Một cái là tính chất oxy hóa rất rõ này, khử cho này, ô nhận này, một anh nhận này, oxy hóa này, khử A cho đi này, và một anh thì không có tính chất đấy, hai cái tính chất đều không có, đúng không? Vì vậy nên chúng ta gọi là một khử, một nhận, hay nói khác là tính chất hóa học của nó cực kỳ khác nhau. Thế thì chúng mặc dù chúng là ba cái nguyên tố này liền nhau trong bảng tuần hoàn, nhưng chúng có tính chất hóa học cực kỳ khác nhau. Vậy chắc chắn rằng cái cấu trúc điện tử của chúng phải khác nhau, bởi vì các bạn biết được rằng là cái việc là phản ứng oxy hóa hay khử nó phụ thuộc vào cái điện tử lớp ngoài cùng. Đây các bạn nhìn đây này, nhận một E vào hay bỏ một E đi đều là liên quan đến điện tử lớp ngoài cùng. Vậy nói rằng cái cấu trúc của điện tử lớp ngoài cùng có vẻ khác nhau lắm đây, thì nó mới có thể khác nhau về tính chất hóa học như thế này. Thì it is the answer for the question. In many electron atoms, all electron cannot be in the same lowest energy states because, for example, you consider some adjacent element in the periodic table. You can see that the chemical properties of them are very, very different together. So the electron in the outermost cell are very, very different together, or the outermost cell or the electron in the energy level, they are very, very different together. So yes, it is the answer for this. Yes. Let's see. Yes. Yes, this is the difference between two elements. You need to have some more concept. This is a negativity, electron negativity, and electron affinity. Yes. So who know electron negativity means in Vietnamese? Yes, độ âm điện. Các bạn khác chưa biết thì có thể ghi vào độ âm điện. Yes, and electron affinity. Electron affinity. Who know? It is ái lực điện tử. Các bạn biết ái lực điện tử chưa? Chưa? Thằng sodium này nó có ái lực điện tử rất cao nên là high electron affinity, độ âm điện. Fluorine là độ âm điện. Fluorine là độ âm điện. Độ âm điện thấp, ái lực điện tử cao. Thằng này nó mới có ái lực điện tử cao chứ nhỉ? À không, đúng rồi. Cái này là natri cộng. Affinity. Ái lực điện tử. Ái lực điện tử và độ âm điện. Độ âm điện của thằng kia là cao. Đúng rồi. A cộng sẽ có ái lực điện tử lớn. Đó. Thế thì bây giờ các bạn mới có cái nội dung về Pauli's exclusion principle, là nguyên lý loại trừ Pauli. In 1925, Pauli discovered the exclusion principle like this. This is the content of exclusion principle. No two electrons can occupy the same quantum mechanical state in a given system. You need to remember that quantum mechanical state. So I would like to ask you, how many yes, one quantum mechanical state can be given by how many quantum number? How many quantum number? How many quantum number?
For
yes.
quantum number.
Yes, for quantum number, they are
the principal quantum number.
Yes, principal,
Orbital quantum number.
orbital,
Magnetic quantum number.
magnetic,
And spin quantum number.
yes, and spin quantum number. And one combination or the full combination of 4 quantum number can determine one quantum state. Okay, one quantum state. Yes, it is quantum state. Yes, so now the content of Pauli principle or exclusion principle is no two electrons can occupy the same quantum mechanic state in a given system. So I would like to ask you that in one atom, for example, so I have the first, this is electron, and there is another electron, and many electrons around, many electrons, n electron, for example. Yes. So this principle or the Pauli principle state that any electron in this system, any electrons in this system has unique combination of L, NL, ML, and MS. Unique. Yes. For example, you can see two arbitrary electrons in this system that they know state. For example, for E1, N, L, ML, and MS. For this must be different from the state of E2, N, L, ML, and MS. At least there is one different quantum number from two combinations. At least there is one different quantum number in one combination. Yes, the combination of 4 quantum number for each electron is unique, not the second combination the same, not the same second combination of quantum number. Yes, it is clear for you? It is clear for you, O class?
Yes.
Yes. And you need to remember the Pauli exclusion principle. Yes, in this case, you consider a closed atom, a closed atom, or individual atom. Yes, you can see that this. However, when you come to the larger system, for example, I can and this. Yes. For example, I would like to broadening for the larger system. For example, you can consider not only one atom. It is one atom. So Pauli exclusion is right. However, when you have another, it is a molecule. For example, a molecule. So you also can apply the Pauli exclusion principle. So in this system, there are no two electrons have the same 4 quantum number. No two electrons. And even when you have a solid, this is a molecular and this is a solid with three dimensions, L1, L2, L2, and L3 here. You also can apply Pauli exclusion principle for this. So there is no two electrons can have the same 4 quantum number, or each electron has the unique 4 quantum number. Yes, it is the content of Pauli exclusion principle. Yes, Pauli exclusion principle. For example, you can see when you have two same atoms combined together. For example, in hydrogen molecule. Yes, because you have two electrons. You have two electrons in the molecule for hydrogen. So you can see they connect together, and you already know that the electron inside the hydrogen molecule will be in the covalent bond. Do you know covalent?
Cộng hòa trị ạ.
Yes, liên kết cộng hòa trị nhé. So you know that in hydrogen molecule it has covalent bonds. So in this, you need to remember for me that also these electrons are in the same ground state. For example, this also in ground state. N equal to 1, S equal to 1, and N equal to 1, L equal to 0, not S. ML equal to 0, 2. And in this are the same. N equal to 1, M equal to 0, and ML equal to 0. However, they must differ from in the last quantum number. It is MS. For example,